Step by step, you're getting ready to unlock Unreal full power. And to do it, we are going deeper in C++. Welcome to part 3 of our Unreal Engine 5 C++ beginner series. You'll learn what C++ really is and how its program structure works, how to define your own functions, the basics of variables and data types, control flow structures like if statements and loops, a clear intro to references and pointers, the essentials of object-oriented programming, what constructors are, and why they matter. Plus, we'll build a hands-on example together in C++. If you're serious about learning C++, these fundamentals aren't optional. They are the foundation for everything you'll do next in Unreal Engine. And having clarity on them gives you a huge edge as a future game creator. But before we dive in, smash the like, hit, and subscribe buttons and ring the bell to stay sharp with Unreal and level up your dev journey. And don't forget to check out Woolun.com to learn more about the Game Creator Accelerator, a lifetime mentorship program designed for aspiring creators like you. You'll join a private, committed community, access step-by-step courses, get one-on-one feedback, and learn exactly how to build visibility and independence, even in a tough industry. Now, let's get started. C++ is a powerful, high-performance programming language that extends the C language by adding object-oriented features like classes and inheritance. We're going to talk about that in a second. It allows developers to write both low-level, memory-efficient code and high-level abstract logic, making it ideal for building operating systems, video games, real-time simulations, and large software systems. It works by compiling source code into machine code through a compiler, turning human-readable instructions into executable programs that run directly on a computer's hardware, which is, instead of for us to write ones and zeros, it transforms into instructions like these ones you see on the screen, and the compiler transforms that into ones and zeros. Every time that you make an update of your code for your Unreal project, of course, you need to compile before testing the results of your coding. Supported by the API, the application program interface of Unreal, that is adapted for C++, you can extend not only these functions that are originally from C++, but also to control mechanics and elements in Unreal. In this video, we'll continue working with C++ to understand the basic elements of the language. But then we're going to start working with Unreal and C++. We're taking the same project we finished in the previous video, a very simple example for calculation that we are calling a class from the main CPP file. And then we call the method of add. In the implementation 5 of calculation, we have two functions. And in the definition of these functions, you have in one that we need to pass two parameters of the type float, here a and b, and we are returning another type float. And we also have another function where we pass one parameter, which is of the type float, and we don't return anything. That's why this function is defined as a void. You can also create functions without parameters, like this one inside the main CPP. Look that inside the parentheses, we don't have parameters. If we run our current program, you will see that we have a message of hello world and immediately a 7. I want to add after the hello world, jump to a next line. To do it, I'm just add this, and std, and line. Now let's run. And you have hello world and the 7 on the next line. I also want to copy this section and add it after the calculation. In the calculation, we present out the result of the calculation, and I want to add another jump of line. This way, I can call maybe two different calculations, which will be separated by one line. Let's make this one different. Let's say 5 plus 5. Here we have hello world 7 10 and the jump line of 10. Inside C++, you have different types of data that you can use. The most common are integer, float, character, boolean, and string. Notice that because this is not well compiled, we have an underline that it is red. Let's say that I want to make a comment for this. A comment is a section in your program that won't be executed. It is only for the purpose of reading the content and understanding or presenting information for you to remember things or to transmit that information to other developers. If you want to add a comment for just one line, use the slash like this. But if you want to make the comment for a couple of lines or a group of lines, you can start with the slash asterisk and then closing the same thing at the end of your comment. Going back to the type of data, integer refers to integer numbers. Float, the same thing, but for floating numbers. Characters data is used to store a single character, such as a letter, digit, or a symbol, and it typically occupies 1 byte, which is -28 or 127. Even though the character type is designed to represent characters like, let's say, A or 7 or hashtag, a character is technically just an integer that corresponds to an ASCII code. For example, if you declare a character and you assign the value of A, that will have an ASCII value of 65. It might be one of the most difficult concepts in terms of data type to understand, but once you get into the examples, you will see how it works. The other two are the booleans, which are values of true or false, and a string, which stores a text surrounded by double quotes. Now let's talk about variables. Variables in programming is like a container or a box that holds information that you want to use later. Imagine that you have a label that says score and you put the number of 10 in the box. Now, whenever you in the program you use the score, it knows that the value is 10. Later, you can also change what's in the box. For example, you can update the score to 20. And to declare a variable, you need to use a define type, one of those that we have here. Let's do a simple example. After the calculation, let's write this. Integer health equals 100. That's a declaration of a variable. We're creating a variable that will be named health, which is of the type integer, which value is assigned to 100. Now you can also use a float, let's say speed, and the value will be 50f. You can also use the boolean, and let's say that is damage, and assign the value to false or to true, depending on where you want to achieve. And let's do another one with the string type name. Let's call my name, which is Tony. I want to take the case of the string because you can notice that we have a red underline, and when I was trying to write the string, the IntelliSense didn't give me a suggestion for it. That means that we need to call this line of code in a different way. It is extremely difficult to remember all the libraries and all the syntax that you have to use. So today you have the support of ChatGPT to find information about why this kind of line of codes is not working. Here I open my ChatGPT and ask a very simple question. What the library I have to add to C++ to use the data type string? Let's see what is the suggestion. To use the standard string data type, you need to include the string header. That could be part of the thing. Also, make sure that you're using the standard namespace or prefix, which is this one. So I think, in fact, that I don't have to use the string. So let me try the standard and then the string name, std. And there you go. We have the suggestion directly from the IntelliSense. And let's see if this is working. Build and compile. 1 succeed, 0 failed, 0 up to date, everything is looking good. The less includes you add at the top of your program, the easier it's going to be for the compiler and to process all your lines of codes. This moment is pretty simple because our program is very small, but with big projects, That's a very good consideration to keep in mind. There is a second suggestion in the answer of ChatGPT that I want to mention, which is using the namespace std. This saves you from having to write the std : to call these functions, and in our case, the std to call the string on this line of code. To do it, I just have to add at the beginning using namespace std. A namespace in C++ is like a container that holds a set of names, like variables, functions, or classes, and it's created to avoiding naming conflicts. Imagine that two different libraries both have a function called print. Without the namespaces, your program wouldn't know which one to use. Namespaces solve this problem by grouping related code under a unique name. In this case, for this example, that's why here it mentions that it is not always recommended. But at this moment, we have control over our coding and we can use it without problems. Now, I don't have to write the std at the beginning. I can remove this section and see that the compiler is still working. I can remove this section as well, and the compiler is still working. Let's go to build, compile, and as you can see, 1 succeed, 0 failed. The next concept I want to mention is an array. In C++, an array is a collection of values of the same type. That's very important. They have to be the same type, stored in a fixed size list. Imagine that the array is like a row of boxes where each box holds a value and you can access them by number. These numbers are called the indexes. Let's show the declaration of an array with a simple example. We're going to create an array which components are going to be strings. All the elements of this array will be string. Now let's call this fam names. And because it is an array, we use this notation. You open and close brackets. And now let's add the elements. The first one, let's call Tony, Jen, and Nat. This is the declaration of an array of type string where it has 3 elements. Now, if I want to get one of these elements, I just have to use the cout, and let's say I want the first element of this array, which will be the 0. It's important to mention that the arrays always start in 0. So the first element is the 0, the second is the 1, and so on. And to complete this line, let's add an end line. Run the project. And here we have Tony. If I want to check the last one, in this case, will be the number 2. Save. And here we have Nat. The next subject I want to cover for programming is the flow, controlling the flow of a program. And I'm going to start using the if statement. In C++, you can use a condition. Let's call this condition Boolean condition, which can be anything. And let's establish that variable to true. It is of the type Boolean, and we assign the value of true. In C++, you can use the if to define if a condition is appearing or not. And if it's not, you can use the else to define what other things you want to do. So let's say cout, and we're going to present condition is true. And as usual, end line. And let's repeat the same thing on the bottom, but condition is false. This way, when the variable that we are analyzing at the beginning of the if is true, then they will execute this, and if not, they are going to execute this section. Let's test it. Right now, it is true. Let's run it again because I closed the window. And here you got, condition is true. And let's change now the condition to false. And run again. And condition is false. So in one case, it moves in this direction and the other one moves to other. Let's say that after I check that the condition 1 is true, I want also to confirm a second condition after I execute this group of code. Then let's say that the second condition is condition extra false. You can add an after the else and if to check that other second condition. Then if the condition extra is true, you will continue the flow of your coding inside this section. Now imagine that you have a variable that can have different values. And when I mean different values, it's more than 2. It's not as simple as true or false. It can have more than those values. In that case, we're going to use the switch statement. Let's write switch, and we need to compare one expression. It's called expression to check. The expression to check, that's one limitation for the switch statement in C++, is that it has to be an integer. So let me declare this expression to check as an integer and assign the value of, let's say, 2. Then we're going to establish the cases. Let's say that the first case is 1, and then we can say something like cout, it is 1. And then we're going to break this process. We don't want to continue checking the other possible cases. Now let's say case 2 and do something similar. So I will copy and paste, but will be 2. And let's say that beyond the case 2, the rest are going to be nothing important for us. So we're going to call it default. And in this case, it is other values different than 1 or 2. In fact, and 2. I forgot to add the end line, so let's copy this one. Save our project, and right now the expression to check is 2. So let's see, it is 2. Fantastic. Now let's put another value, let's say 20, then it should be, it is other value different than 1 and 2. Save, run. It is other value. Oh my God, forget about my English at this moment. What matters is that it is working. The next subject I want to cover is the loop statements, and the loops are cycles that has to continuously repeat until a certain condition is achieved, and then you stop the cycle and move out of the loop. One of the most used, I'm going to say, talking by myself or for my own experience, is the for loop. Let's put it a very simple example. Let's say that I create a for, and first we declare the variable and where that variable is going to start. The second parameter of the for is defining the condition while the condition that you will use to run this loop. Let's say that I will define that I has to be less than 5. That means that we continuously run in this loop while the condition that I is less than 5 is accomplished. And then we're going to define how we're going to increase that condition. When you add a double plus, it means that you are going to increase the value of I by 1. And now let's present this with a cout. So cout, the value of I, and then end line. End line. Let's test it. Here you have 0, 1, 2, 3, 4, and then the cycle was completed. Another loop expression is the expression of while or do while. Let's present it with a simple example. Let's say integer j, and we define this value on 0. We started with 0. Now we're going to add a while, and we are going to check only the condition to keep running this while. Let's say that j has to be less than 10, and then we call cout j and the end line. Now, the thing that where you have to be very careful when using this while is that you have to increase the condition. Look that in the declaration for the for, we use the plus plus I. This is running the cycle and then increasing the I. But here we don't have anything that says, okay, increase the value of j. So we have to define it inside the while just before the end of the code inside the while. In my case, will be plus plus and j, because this is the variable we use here. Now let's run. And we have first the cycle for the I, and now is 0, 1, 2, 3, 4, 5 until 9, which is the cycle for the j. You can also use a similar approach. Let me copy this and paste it on the bottom and change the J for, let's say, a set. But the difference is I'm going to do something and then I'm going to check the condition. Instead of the while, let's remove this line and I will write do. What I'm going to do, in this case, I'm going to present the set. I'm going to increase this set and then I'm going to check the condition. Set is, let's say, less than 4. To make this more clear, I'm going to comment the first group of lines of the first, 4 and the first while. Save. And now let's run and see what happened with the set. Now you can see 0, 1, 2, 3. What is the difference between this do and the while? Well, the while checks the condition first and then execute the code. In the case of the do, they execute the code and then check the condition. Let me expand this comment to the do and let me copy. It could be for any of this, but let's take a while loop like this one. Consider for this case that there might be a condition that will be presented while you're running the while that will make you cut the process, not finishing until checking the value of 10. Let's say that we created a Boolean count x, and I'm going to call it false. Well, not call it, I'm going to assign the value of false. Now I'm going to check here if j is bigger than 5, count x will be true. So I'm changing the value of count x when j gets over 5. The next step is to check the condition to define if we are going to continue the while or we're going to break it. So if count x, which means if count x is true, then I want to break. Now let's test it. So we reach to the number 5 and then we're moving out. We never reach the number 10, which is the limit for the while, because we achieve the j equals to 5, the condition is true, and then we make the break of this while. At this moment, I want to clean this entire project. Let me remove first the comment on the bottom. And I'm also going to close for the second calculation and calculation CPP. Let's stick only to our main CPP. In this section, we're going to talk about references and pointers. And for that, let me create a simple function that takes two values to be Adam and the main function, which will be, let's say, x is equal 1 and y is equal 2, and presents a cout that will be the add of x and y. When we run this project, we start with the main, and the first thing we do is assign the value of integer for x and y, and that is taking space in memory. But when we call the add, we also are generating new variables of a different type, which are float, and they are taking their own space in memory. After this cout, you can call it again, and let's say add 2.2 and 4.0. And in the second call, we assigned a new value for a and b, but we're still keeping the x and y, and they are not related. Now a will be 2.2 and b will be 4.0, but the x will continue being 1 and the y will continue being 2. Because we're always trying to save a memory in our programs, in C++ and also in video games, we could use something called the references. A reference variable in C++ is like a nickname for another variable. When you create a reference, you are not making a new variable and opening a space in memory for a new variable. You're just giving another name to an existing one. Let's make a very simple change. In the float function, let's add an ampersand before the a and before the b. That is telling the function that this is going to be a reference variable. What you're presented with immediately is something great. As you can see, we have the red underline saying that we have a problem in the call to this function. And the reason is that these variables that we define here are different than the type that it is in the call of the function. So let's change the function to what they should be, which is integers and another integer. Now you can see that we don't have errors. Of course, in the second we have errors because these are float values. So let's remove the section for the float, but for the second we have it. Why? Because this is not an integer and it has to be a float. Not really. Look, we just changed it to integer, but now we still have the same error. Why? Well, because this is not a variable that is set in the memory. When we use references, we need to pass variables and we're going to name it in another way, but we are pointing to the same original variable, in this case, x and y. For that reason, you can't make this call. Now, let's do something even more interesting. Before making the call, I'm going to present the values of x separated by the value of y. So let's make some separation here, and then y, and of course, end line. If we run this, we see we have 1, 2, and then the addition, which is 3. At this moment, we are going to make a small change, and the change will be this. I'm going to add an extra value for A, and I'm going to add an extra value for B. Because these variables are passed by reference, they are pointing to the original value of x and y. Before we call the add, the value of x and y's are 1 and 2. But after we call the add, the values will increase the x by 1 and the y by 1 as well. So we'll have x value 2 and y value 3. Let's call the cout again, but after the addition. Oh, I forgot to add an extra line after this. So we can add here end line and run. And now we have 1, 2, the 5, which is the addition between the 2 and 3, because before we return, we add 1 to A and 1 to B, and now we have 5. And then we check that once we finish the add, the values of x and y were updated. I am presenting you with the power of references. The other concept I want you to keep in mind is the concept of pointers. When you define a variable, that variable is stored in a place in memory that has an address. A pointer is a variable that stores the memory address of another variable. Let's put it in simple words. Think of a pointer as a map that tells you where to find something in memory. It's not the value itself, but where that value lives. To explain, let me remove this and erase the float because I don't need it for the example. Let's create a variable integer, say num_orig, and assign the value of 10. That variable has an address in memory. The address is not the value, it's where it is located in memory. Now let's create the pointer. In this case, an integer, and let's call it PTR for a pointer. And I'm going to tell this the address of the num_orig. To get the address, we use the ampersand and num_orig. The pointer, this variable, holds the address of this variable called num_orig. In fact, if you go cout and say PTR, what you will get is the address in memory. Look at that. Here is the address in memory for that variable. But if we want to get the information of the value that is stored in that address, then we use cout asterisk 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 pointer and line. Now we have the address where it is saved in memory and the value of the variable that is in that address. Now let's create a similar example to the one we did on reference. Let me remove this and add a float. In fact, I'm going to use an integer add, where we're going to pass two pointers, integer pointers, by the way, and we're going to return the addition of the values that are in the address of that pointers. In the main, I'll define x, let's say, as value 1 and y as value 2. I now call the cout of add, where we're going to pass the address of x and y, which is x and ampersand y. Run. And here we have the result, which is 3. Pointers and references are concepts that you will constantly use in C++ and in C++ for Unreal. A deep understanding and use of these concepts will help you save memory and make your programs more efficient. The next subject is about what is at the core of C++ and many other languages just like Java and C++, C#, etc., which is the object-oriented programming, or OOP. Object-oriented programming is a way of writing programs by thinking in terms of objects, just like real life. Each object has properties, which are data and attributes, and has behaviors, which are functions or methods. Imagine this with a car. Properties for that car could be color, speed, fuel, and behaviors can be drive, brake, honk, etc. There are 3 major pillars when we talk about the OOP. The first one is called encapsulation. Imagine that you have a remote control car. You press buttons to make it move, turn, or stop, but you don't need to know how all the gears, wires, and circuits work inside. That's encapsulation. It means hiding all the messy stuff inside and only showing what you need. In programming, it's like putting data and functions inside a box called a class, unlocking the box so no one messes with the wrong parts. Only safe ways to use it are allowed. The second is called inheritance. Think about a child who has the same eyes or smile as their parents. In programming, we do something similar. A new class like a child can inherit things from another class, like a parent. For example, if we have a class called animal with things like eat and sleep, we can make a dog class that inherits those actions and maybe adds more like bark. It saves time because we don't have to repeat code. The third one is called polymorphism. Let's say that you have a toy that does different things when you press different buttons, but the toy is still called robot. Polymorphism means many forms, and it lets you use the same word like a function name to do different things depending on who or what is using it. For example, a draw function could draw a circle, a square, or a triangle. It depends on the object calling it. The name stays the same, but the result changes. The benefits of using OOP are, first, easier to manage complex code. The other is that the code is reusable via inheritance. The code is also flexible and scalable via polymorphism, and it helps with security and data protection via encapsulation. Let's remove this to create a new code. In fact, I'm not going to use the calculation H, so let's remove it. Let's create first an example of encapsulation. I'm going to build a new class that I will call animal, and on it, a private variable of the type string, name. And let's define animal string n, where we're going to assign the value of n to name, the private variable that we declared a moment ago. In the public section, we're also going to add a method called speak with no variables, and it's going to be a cout for the name and makes a sound, and end of line. It is called encapsulation because we define a class animal, and inside that class animal we set a private variable that is handled using methods that are public related to that class animal. The sensitive data I want to control in this case is name. I'm not giving access to that directly, but you can control the name using the methods that are provided here. Now let's talk about inheritance. For inheritance, I'm going to create a new class that I will call dog. But it turns out that dog is a class of the type animal, which was the class that we created on the top. Because dog is of the type animal, it inherits the property name and also the methods associated with the class animal, which are void, speak, and animal to assign the value of name. Now I can initialize a dog string n as an animal n. And because dog is of the type animal, I can use this same function that I created previously for animal to assign the value of name, of the variable name, to this parameter, which is n. In our case, will be this n that belongs to dog. And now I can also use polymorphism. Let me write the comment here. Because I will use the same function that was defined previously on the animal, but in the cout, I am going to say the dog barks, which is the sound that the dogs made. Look that it is the same call of the same function, but I am adjusting for my class, which is dog. Now I can repeat this same process, and let's say that now I'm declaring another kind of animal, which will be cat. Cat is also an animal, but in this case, when we're talking about the speak, well, the cat meows. And now let me show you something more about polymorphism and the power this has. I can create a void function that, let's call it make animal speak of the type animal, and I can use that animal and call the method speak. The speak method will call, well, depending on the type of object, the cat, their dog, or the generic animal. The final part, let's create the main section, starting with a dog that we call Rex. Oh my God, Rex. A cat that we call Misty. Let's check these underline errors. Go to here and let's see. Dog cannot access private member declared in class dog. Okay, I know what is happening. By default, when you create a class, everything that is inside the class will be set as private, even though you don't say it. So what I will do is to declare it public, and now I should have access. Perfect. And the same thing will be for the cat. Build, compile, no errors. Fixing this error, by the way, get me to another important concept in object-oriented programming, which is the constructor. You will see that in the top of the animal, of the animal class, we have this section. This section, look, that starts with the same name as the class, and then adds some methods or some things to do. The same thing happens with the dog, and the same thing happens with the class cat. A constructor is like the setup crew that gets everything ready at the moment you build, the moment you create something. A constructor in C++ is a special function that is automatically called when an object is created. Its main job is to set up the object, like giving the name, starting a value, or preparing it to be used. When we execute the lines 46 and 47 at the moment, which is we instantiate the dog class with dog and the name Rex, and the cat with the name Misty, this is the default action, the default method that will run. That method is the constructor. Now let's do a couple more things in the main section. Again, we're going to use polymorphism. Polymorphism. Let's create an animal of, let's call it A1, and let's aim to the direction of dog, where dog is located. And let's create another animal, animal, which is another pointer because we have the asterisk, to the direction of cat. The next part is using the function we created here, make animal speak. And first we're going to pass A1, and then repeat the process, and we're going to pass A2. And because this is an integer main, return 0. Let's run and look what will happen with the exit results. We have Rex makes a sound and Misty makes a sound, which makes no sense because this is not what we were looking for. This is the message that is by default set for an animal. So why is this happening? Well, the reason is pretty simple. Because when we call this polymorphism function, we are saying that we're going to use the animal, the default, speak method for the animal. Now, what happens if we want to call this speak method, but as it is defined on the child class? Well, to do that, we're just going to add in the parent class before the void for the speak, the virtual, just virtual. And that will let them know to the compiler that if there is a speak method defined for a child of this class, in this case, dog or cat, then they are going to execute the one corresponding to that child. Let's run. Now you have the dog barks and the cat meows. If this video added value to you, like, subscribe, and ring the bell so you never miss tips and tutorials on Unreal Engine, the next video of this series, and how to build your successful career in video games. Until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.